Hello dear students, thanks to all for watching my lecture. Today I am discuss about important topics, angular displacement and what is angular displacement and what is linear displacement. My lecture actually derived for HSC Physics English version, Physics first paper chapter 2 vector. My dear student, in this chapter already we learned already we complete one topics. One is scalar quantities, vector quantities, fundamental quantities and derived quantities. My dear student, in our first lecture already we learned what is quantities, what is fundamental quantities, what is derived quantities. According to the expression, quantities mainly two types. One is scalar quantities and another is vector quantities. As the name of this chapter is vector, so all the vector quantities we must have to learn perfectly and clearly without any hesitation. If you face any kind of the difficulties for understanding my lecture, then please write down your comment on the comment section. I am trying to give you the right answer, okay, on your particular problems. My dear student, in our previous lecture we learned displacement. Displacement mainly two types. One is displacement. Displacement mainly two types in our physics. One is linear displacement, another is angular displacement. Angular displacement. My dear student, what is linear displacement? Suppose if a body straight journey from here at point A to at point B, okay, as this is the shortest distance between A to B and this is the linear path A to B, okay, how much time is needed to cover this distance? Suppose t time is needed. The linear displacement is represented by S symbol. S is a linear displacement. Why? Because this is the initial point and this is the final point. This is initial point and this is final point. The minimum distance between initial point to final point is called linear displacement. My dear student, in case of the angular displacement, then a object must be rotated. Suppose this is the rotational path, and if a body straight journey from here this point A and this is the initial point, okay, if this body start journey from A to B, in this situation, as this is the curved path, so we cannot call this is linear displacement. In this situation, when any kind of the object rotate around the circular path, in this situation the displacement will be angular displacement, okay. Again we repeat, when any kind of the object rotate around the circular path, in this situation the displacement is called angular displacement. How we can measure angular displacement? With the angle we can able to measure angular displacement. Suppose this is the initial point, and this is B is a final point. My dear student, between initial and final we can clearly measure this angular displacement with the help of the angle. Suppose this angle is theta. How much time is needed to cover this angular displacement? T time is needed. Within time t, this body covered angular displacement theta A to B, okay. My dear student, in case of linear displacement, we get linear velocity, okay. In case of linear displacement, we get linear velocity, and in case of the angular displacement, we get angular velocity. So velocity. So velocity also two types. One is linear and another is angular. Suppose in case of if we measure for time t, the linear displacement is s. For 1 second, the linear displacement will be s divided t. This is called linear velocity. My dear student, if any kind of the object is rotated around the circular path for time t, the angular displacement is theta. If we measure for 1 second, the angular displacement theta is a angular displacement. My dear student, theta is angular displacement. So for time t, the angular displacement is theta. For time 1 second, the angular displacement will be theta divided t. This theta divided t is called angular velocity. We represent angular velocity by Greek symbol omega. Okay, by Greek symbol omega. Omega is a angular velocity. Okay, my dear student, we represent angular velocity by Greek symbol omega. Okay, now if we measure in case of angular displacement and angular velocity, we also discuss perfectly and clearly. Suppose again we draw a diagram. Suppose this is the circular path. If a body starts journey from here, point A, this is the initial point. If this body go from here, then this is the final point. So in this situation, the time is needed theta. In case of for time t, the angular displacement will be theta. In case of time x second, the angular displacement will be theta divided t, and this theta divided t is called angular velocity. So this is the equation for measuring angular velocity, angular displacement and displacement and time. Unit of angular velocity will be radian per second. Displacement represented by radian, angle represented by radian, and time is second. Now my dear student, my question to you, if a body start rotate from here, start journey from A, and after completing a full cycle and again comes here at point A, like this. Suppose this, if this point start journey from here after completing a full cycle and comes here, how much time is needed? Suppose t time is needed. How much time? T time. T is a time period. After time t, this body comes again here after completing one cycle. Okay, how much time is needed? Suppose t time is needed. For time t, in this situation, what will be the angular displacement? The angular displacement will be twice pi. Okay, now we calculate why the angular displacement will be twice pi. If this body comes here, then the angle will be 90 degree, and if this body comes here to here, then this angle will be 180 degree. And again, if this body comes here from here to here, then this angle will be 270, and if this body comes here to here, then the angle will be 360. This 360 will be 2 pi, and time is capital T. Capital T is the time period. Capital T, what is capital T? Capital T is a time for rotating, completing one cycle. After completing one cycle, the time is T. Okay. For time T, the angular displacement will be 2 pi. In case of 1 second, the angular displacement will be twice pi divided T, and this twice pi divided T is called angular velocity. My dear student, in our previous section, we learned angular velocity is omega. Omega is theta divided t. Now we learn another equation, twice pi divided t. Okay, twice pi divided t. My dear student, now my question to you, if a body rotates for complete one cycle, the time is t. In this situation, the rotation angular displacement will be twice pi. If this body rotates 2 times, that means if we double 2t, then this will be double. Okay, double. If we 3t, then this will be 3 into twice pi. If we 4t, then this will be 4 into twice pi. Okay. In this situation, now if we calculate for time t, if the total rotation is n into twice pi, suppose n is a number of rotation. Okay, for one rotation the angular displacement will be, for one rotation the angular displacement will be 2 pi. For one complete rotation the time is t, and for 2 times of the rotation the time is 2t, and angular displacement will be 2 into 2 pi. In case of 3 times, the rotation angular displacement will be 3 into 2 pi. In case of 4 times, the angular displacement will be 4 into. In this situation, suppose this is the time. This time, within this time, the number of complete rotation is n, and so total angular displacement will be n into 2 pi. Now, if we want to measure for 1 second, then we get twice pi n divided t, and this is also called angular velocity. So, my dear student, here we get another equation, twice pi n divided t, and this is the equation for measuring angular displacement. My dear student, I think that all of you clearly understand what is linear acceleration, what is linear displacement, and what is angular displacement, what is linear velocity, and what is angular velocity. Now, I am trying to develop a relation between linear velocity and angular velocity. Okay, the relation between linear velocity and angular velocity. Relation between, this is very important part, relation between linear velocity and angular velocity. My dear student, this is very important part. Suppose this is the circular path. If a body starts journey from here, after completing one cycle, suppose the radius of the circle is r, after completing one cycle, how much time is needed? Suppose in case of time t, the angular displacement will be twice pi. In case of 1 second, the angular displacement will be twice pi divided t. This is called omega. Okay, my dear student, if we measure for time t, how much the distance will be covered? This is the circumference of the circle. How much time is needed to cover this distance? This distance for covering twice pi r is a distance. Okay, twice pi r is a circumference. If we check how much distance here, this distance will be twice pi r. Okay, how much time is needed to cover this twice pi r distance? Suppose time is t. So again, if we measure for time t, the total distance covered by the body is twice pi r. In case of 1 second, the distance will be twice pi r divided t. This is called velocity v. Okay, velocity v is equal to twice pi r. So the value of twice pi divided t is omega, so omega r. So this is the special relation. My dear student, here omega is a vector quantity. Here omega angular velocity. Okay, r is a radius of a circle. My dear student, radius is counted as a vector, radius vector. Okay, r is a radius vector, and omega is angular velocity. This is also a vector. If we represent, this is a vector and this is also vector, and from these two vector we get a vector v also a vector. My dear student, in our physics chapter there are two types of the special operation. One is scalar product, another is vector product or cross product. What is cross product? Cross product is nothing but, suppose we have two vector quantities. How many quantities we have? Two. From two vector quantities, if we apply cross product, then we get a new vector. From the two vector quantities, if we get a new vector, then we apply cross product. We apply cross product. My dear student, suppose তোমাদের কাছে ধরো দুটো ভেক্টর কোয়ান্টিটিস আছে। কয়টা ভেক্টর কোয়ান্টিটিস আছে? দুইটা। তার দুইটা ভেক্টর কোয়ান্টিটিস থেকে যদি তুমি একটি মাত্র ভেক্টর কোয়ান্টিটি বানাতে চাও, দেন ইউ মাস্ট অ্যাপ্লাই ক্রস অপারেশন। সাপোজ তোমার কাছে যদি দুইটা ভেক্টর কোয়ান্টিটি থাকে, তুমি যদি একটা স্কেলার কোয়ান্টিটি বানাতে চাও, দেন ইউ মাস্ট অ্যাপ্লাই dot product. Dot product and cross product both are the special operation in our this chapter. From these two operation we get in scalar quantity and get a vector quantity from the two vector quantities. My dear student, I think that all of you clearly understand. So suppose we have two vector for cross product, cross producte কি হবে? টু ভেক্টর থেকে একটা নিউ ভেক্টর জেনারেট হবে, ওকে। ক্রস প্রোডাক্ট, সাপোজ টু ভেক্টর, সাপোজ আমাদের কাছে একটা ভেক্টর আছে ওমেগা ইজ এ ভেক্টর, আর ইজ এ রেডিয়াস ভেক্টর, ওকে। If we apply here cross product, then we get a new vector. The new vector is velocity, so v is equal to this, okay. My dear student, this is the special operation in our physics. Suppose we have two vector, one is omega means angular velocity is a vector quantity, and r is a radius is a vector. If we apply cross product here, then we get linear velocity. As in our previous section we learned the relation between linear velocity and angular velocity. V is equal to omega r. My dear student, I think that all of you clearly understand this notation. In your books this notation is given. You just see V, we can write V vector, linear vector is equal to omega cross r. The cross product of angular velocity and radius vector is called linear velocity, okay. Now we discuss about momentum. In our physics, momentum also two types. One is linear momentum and another is angular momentum. My dear student, momentum also two types. One is linear momentum, and another is angular momentum. তাহলে momentum, তাহলে প্রিয় শিক্ষার্থী, আমাদের হচ্ছে momentum দুই ধরনের আছে. One is linear momentum, another is angular momentum, okay. What is linear momentum? Suppose this is the body, the mass of the body is m and linear velocity is v. If the mass of a body is m and linear velocity is v, then what is linear momentum? Linear momentum is nothing but it is one kind of the product of mass and velocity. Product of mass and velocity is called linear momentum. We represent linear momentum by p, okay. M is a scalar quantity and v is a vector quantity. If we product any kind of the vector quantity by scalar quantity, then result will be vector. So linear momentum is a vector quantity, okay. My dear student, what is momentum? Momentum is nothing but it is one kind of the product of mass and velocity is called linear momentum, okay. My dear student, in case of the angular momentum, what is angular momentum? In our previous section we learned, if any kind of the body start rotate around the circular path, when the body rotate around the circular path, if this is the radius of the circle, okay, then here has two types of the velocity involved. When any kind of the body rotate circular path, অর্থাৎ সার্কুলার পাথে যদি কোনো একটা অবজেক্ট রোটেট করে তাহলে সেই অবজেক্টের মধ্যে দুই ধরনের ভেলোসিটি থাকে, একটা হচ্ছে লিনিয়ার ভেলোসিটি, একটা হচ্ছে অ্যাঙ্গুলার ভেলোসিটি। ভি মানে লিনিয়ার ভেলোসিটি and omega is the angular velocity. What is the relation between them? V is equal to omega r. My dear student, this is very important. Suppose the direction of angular velocity will be along the circular path. This is the omega. And if we draw a tangent here, then this tangent represents the direction of the linear velocity. Okay? If this body comes here, then all the time the direction of angular velocity will be around the circular path. Again, if we draw a tangent here, then this tangent represents the linear velocity. If this body comes here after rotating from point A, again if we draw a tangent here, then this is represent the direction of the linear velocity, and along the circular path the direction of the angular velocity, all the time along the circular path. Okay, my dear student, what is angular momentum? Angular momentum is nothing but, suppose here is a body, okay, this body has mass, and at point A if we draw a tangent, then this tangent represents the linear velocity, and r is a radius vector, okay, and this direction represents the angular velocity. My dear student, now we try to find out the angular momentum. We represent angular momentum by L represent the angular momentum. Okay, what is angular momentum? As this body has mass at linear velocity, so this body also has linear momentum. Okay, linear momentum represented by P, and r is a radius vector. As angular momentum is a vector, so we can represent r by L. Angular momentum কে আমরা L দ্বারা রিপ্রেজেন্ট করলাম। এখন কি হবে? The product of linear velocity, the cross product of linear velocity and radius vector is called angular momentum. My dear student, as P is a linear momentum, R is a angular momentum. After completing this cross product, then we get a new term. Now my topics আমরা এই পর্যন্ত থাকবো। আপাতত তোমরা এটা মাথায় রাখবে যে লিনিয়ার ভেক্টর এন্ড রেডিয়াস ভেক্টরের ক্রস প্রোডাক্টে একটা আমরা নতুন ভেক্টর পাবো, সেই নতুন ভেক্টরটাকে আমরা বলবো অ্যাঙ্গুলার মোমেন্টাম। ওকে মাই ডিয়ার স্টুডেন্ট, আই থিঙ্ক দ্যাট অল অফ ইউ ক্লিয়ারলি আন্ডারস্ট্যান্ড। তাহলে আমরা আপাতত এই পর্যন্ত রাখবো। এই পর্যন্ত যদি আমরা জানতে পারি তাহলে মোটামুটি আমরা পরের যে পার্ট যেটা আছে সেটাতে আমরা যাব। টর্ক নিয়ে আমরা একটু কাজ করি। তাহলে এখন আমরা যাব হচ্ছে টর্কে। What is torque? Torque is nothing but it is also angular force or rotational force. Suppose here has a object. If we apply F amount of force and this object moves following the linear path, in this situation this is the linear force. This is linear force. Okay. Suppose here has a body. This is a body. If we apply two force, suppose the direction of this force is F and direction of this force is also F. If same amount but opposite direction of the two force apply on the body, then the name of this two force is called couple force. COUPLE, couple force.